Good morning children. Today we have to learn the new topic sequences and series. So what's a sequence? You all know what's a sequence. Sequence means it's a pattern. So look at the first sequence 2, 4, 8, 16, 32 etc. 1024. So each term this 4 is obtained by multiplying 2 to this 2. Then 4 into 2 is 8, 8 into 2 is 16, 16 2s are 32 like that. So for the sequence we can write the nth term or we know how to write the next term. That is also possible for this sequence. And it consists of finite number of elements, finite number of terms. So it's a finite sequence. The next one 3, 3.3, 3.33, 3.333. So next term is 3.3333 like that. And etc. means there are infinitely many terms. So it's an infinite sequence. Then third one is 1, 3, 5, 7, 9. So each term is obtained by adding 2 to the preceding term or set of odd numbers, collection of odd numbers, odd natural numbers. And here also it is an infinite sequence, and for this sequence we can find the general term, nth term. Okay, since it follows a particular pattern. Look at the last one 2, 3, 5, 7, 9, 11 etc. What kind of numbers? They are prime numbers. So it is not possible to write the general term, nth term. So for such sequences can be described by verbal description only. Okay, so these are sequences. Then what's a series? Series means let A1, A2, A3 etc. An be a given sequence. Okay, let A1, A2 etc. An be a given sequence. So it's a finite sequence and there are n terms. Then what is a series? Series means A1 plus A2 plus A3 plus etc. plus An. This expression is known as the series associated to given sequence. So understood the difference? A1, A2, A3 etc. An. That's a given sequence. Then the series associated to this sequence can be written as A1 plus A2 plus A3 plus etc. plus An. So this series is finite since the given sequence is finite. If the sequence is infinite, then the corresponding series infinite. Then this A1 plus A2 plus etc. plus An, that can be expressed in another way using sigma notation. So sigma I can write a generally I can write AK, where K is from where to where, the starting is 1 and ending at n. So K is from 1 to n. This is same as this. Okay. So if sigma AK where K is from 1 to n means for this K you can give the values 1 to n. So the first term is A1. Then sigma means sum. So you have to put plus symbol, then write the next term. A, give the next number. So AK is equal to 2. Then plus, next is A3 plus etc. plus up to which number? N. So An. If it is an infinite series, instead of this n, what we write? Sigma K from 1 to infinity, AK. So we have to write A1 plus A2 plus A3 plus etc. 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 It's an infinite series. So understood the difference, series and sequence. Sequence means A1, A2 etc. An, that is a sequence. Then the corresponding series is A1 plus A2 plus etc. plus An. Then we can use the sigma notation for representing this series. series can be finite or infinite. Now the question, write first 5 terms of the sequence whose nth term is an equal to minus 1 raised to n minus 1, 5 raised to n plus 1. So here the general term, nth term is given. We have to write first 5 terms. You all know how to do this. N minus 1, 5 raised to n plus 1. So a1 means give n is equal to 1. So minus 1 raised to 1 minus 1, 5 raised to 1 plus 1. So minus 1 raised to 0, 5 square. Anything raised to 0 is 1. So 1 into 25, that's equal to 25. The next term a2, minus 1 raised to n is 2. 2 minus 1, 5 raised to 2 plus 1. So minus 1 raised to 1, 5 cube. That's equal to minus 1 raised to 1 means minus 1 into 125. That is minus 125. The next is a3. Minus 1 raised to 3 minus 1, 5 raised to 3 plus 1. So minus 1 square into 5 raised to 4. Minus 1 square is positive, 5 raised to 4 is 625. So 1 into 625, that's equal to 625. Then 2 more terms, a4 is minus 1 raised to 4 minus 1, 5 raised to 4 plus 1, that's equal to minus 1 cube, 5 raised to 5. Minus 1 cube is minus 1, 5 raised to cube is 625 into 5. 625 into 5 is 25, 2, then 3, 1. So 3, 1, 2, 5. So minus 3, 1, 2, 5. Then the last term is a5, minus 1 raised to 5 minus 1, 5 raised to 5 plus 1. Okay. So minus 1 raised to 4, 5 raised to 6. Minus 1 raised to even number is positive. Minus 1 raised to 4 is positive number. 5 raised to 6, that is 3, 1, 2, 5 into 5. One, 5, 6 to 5. So that is 1, 5, 6 to 5. This way we can find. Okay. So n is given. We can find the first 5 terms of this particular sequence. What is the 7th term of the sequence? N is given. N means it is the nth term. So a7, 7th term means just substitute n as 7. So 7 square by 2 raised to 7. 7 square is 49. 49 by 2 raised to 7 is 128. Let the sequence an be defined as follows. a1 is minus 1 and an is an minus 1 by n where n is greater than or equal to 2. Find first 5 terms and write corresponding series. So here the sequence n is 2 and more than that, we can write general term an, but a1 is minus 1. So a1 is minus 1, that's the first term. Then the next term onwards we have to substitute in an. So what is a2? For finding a2 you have to substitute in this expression. When n is 2, a2 becomes a2 minus 1 by 2. a2 minus 1 means a1. a1 by 2. What is a1? Minus 1 by 2. Now what is a3? A3 means n is 3. So a3 minus 1 by 3. That is a2 by 3. a2 is minus 1 by 2 by 3. So it is minus 1 by 6. Now a4. A4 is A4 minus 1 by 4. That is A3 by 4. A3 is minus 1 by 6 by 4. Minus 1 by 6 by 4 means minus 1 by 24. 6 fours are 24. Now the next is A5. A5 is A5 minus 1 by 5. That is A4 by 5. A4 is minus 1 by 24 by 5. Now multiply. It is 120. So now we can write sequence then series. So what is the sequence? The first term is minus 1, put a comma, the next term minus 1 by 2, then minus 1 by 6, then minus 1 by 24 and the last is minus 1 by 120. This is the 5 terms of the sequence. Then what is the series? The corresponding series. The corresponding series we can write as minus 1 plus minus 1 by 2, you can put bracket, okay, plus minus 1 by 6 plus minus 1 by 24 plus minus 1 by 120. So this is the corresponding series of this particular sequence. Now the next topic in this chapter is arithmetic progression. Already in 10th standard you have studied this arithmetic progression. So just we can revise. Look these sequences. Arithmetic progression means that is also a sequence. It is defined as in the sequence each term is obtained by adding a constant to the preceding term. And that constant is known as common difference. So look at the first sequence 4, 10, 16, 22 etc. Each term is obtained by 4 plus 6 is 10, 10 plus 6 is 16 and 16 plus 6 is 22. So it's an AP. And common difference, the notation for common difference is D. D is equal to 6. And first term is 4. Okay, first term notation is A. A or A1, A1 or A. Now look at the next sequence. Is it an AP? What is the difference? How to check whether the given sequence is an AP? You have to find the difference, that is A2 minus A1 should be equal to A3 minus A2, that should be equal to A4 minus A3, like that. The difference between two consecutive terms, that must be equal, but the order also important. A2 minus A1, you can't do A1 minus A2. So is it an AP? Minus 1, that's the rule. Minus 1 is minus 2. Now what is minus 3? Minus 1, that is minus 3 plus 1, again minus 2. Then what is the difference between minus 5 and minus 3? Minus 5 plus 3, that is also minus 2. So the difference is same, that means this is also an AP. Now what about the third one? So here the second one, common difference minus 2, the first term is 1. Third one, fraction, again common difference D, half minus 3 by 2, that is minus 2 by 2 is equal to minus 1. Minus 1 by 2 minus 1 by 2, that is same as minus 1. Minus 3 by 2 minus 1 by 2, that is minus 3 by 2 plus 1 by 2, that is minus 2 by 2, that is also minus 1. So common difference is minus 1 and A is 3 by 2. Then what about the last one? Is it an AP? Yes, it's an AP, adding 0. 3 plus 0 is 3, 3 plus 0 is 3, like that. So common difference we can say that it is 0 and A is 3. So common difference can be positive, negative or 0. Okay. Then what is the general term, nth term of an AP? So usually we write the first term as A and second term is obtained by adding d to the first term. So, second term is a plus the common difference. Then the third term is again adding d to the second term. So, a plus 2d and a plus 3d like that. So, what is the nth term? A plus n minus 1 into d. An means nth term. Okay. An is the nth term. D is the common difference and A is the first term. So, n means if we have to find 7th term, then A7 is equal to A plus 7 minus 1 into D. That way you have to write. Now, the sum to n terms of an AP. So, the notation is Sn. First term is, let I write like this, A1 plus A2 plus etc. plus An. The sum to n terms of an AP. Then we have two formulas. One is n by 2 plus n by 2 into first term plus last term. Okay, what is this n? N is the number of terms. A is the first term and L means L is the last term. If last term is given and common difference is not given, then we can use this formula. We need last term, first term and number of terms. So, Sn, sum to n terms of an AP is equal to n by 2 into A plus L. Then another formula is n by 2 into 2A plus n minus 1 into D. Here common difference is given, number of terms given and first term is given. Okay. N means number of terms. A means first term and D is the common difference. Okay. This all you have studied in the last year and we can use this also. Number of terms, direct formula, number of terms, n is equal to nth term minus first term by common difference plus 1. This also you can use. Okay. So, nth term is A plus n minus 1 into D. Then sum to n terms, first n terms of an AP is n by 2 into first term plus last term or n by 2 into 2A plus n minus 1 into D, and number of terms n is equal to nth term minus first term by D plus 1.